So for today's one and only objective, I will be talking about how to illustrate types of data and associated measurement scales. So when it comes to organizing data, there are a few types. We have the frequency distribution tables. These just divide the data into groups and show how many observations are in each group. We have tally tables and stem and leaf plots. These are the least relevant, or at least not commonly used, at least in like stats. They're more used like in lower divisions. But we can see this. You can easily see the spread and how even each table is. Stem and leaf plots use numbers, while tally tables use tally marks. And then we also have histograms. Histograms illustrate the frequency distribution of a data set. These can be commonly confused with bar graphs because the presentation does look pretty similar, but bar graphs you are able to use names as your labels, but for histograms you do have to have numbers. So this one allows the inspection of data for its underlying distribution, outliers, and skewness. So it is also important, like any other data set, to have information on people and the data you are working with. And then the way the histograms are organized is that you list score values on the horizontal axis, and the frequency on the vertical axis. So some important measurement scales. Some common ones would be the central tendency. This is where the score of something tends to center at. And then another common one is a percentile. This is created by adding the percentage of scores that fall at and fall below the percentile you're trying to calculate. Some more common ones are mean, median, and mode. Mean is just the average, so we just the total score divided by the number of scores. Then we have the median, the number right in the middle. The mode is the number that is frequently represented in the data set. And the skewness is just the shape symmetry of the distribution of numbers. And then we have variability, which includes range. It's just the high score minus the lower score. This is the least stable. Then we have variance, and we have standard deviation. So those would all be part of variability and part of the whole measurement scales.